All right, let's dive into one of the most important and honestly one of the most misunderstood principles in all of software engineering, the single responsibility principle. You know it as the S in solid, and I promise you, getting this right is an absolute game changer for your code. So, you've probably heard this a million times, right? A class should do one thing. It's simple, it's catchy, and on the surface, it makes total sense. Seems pretty straightforward. But what if that simple little phrase is actually the reason so many people get this principle wrong? What if it's missing the entire point? Yeah, let's dig into what SRP is really all about.
And here it is. This is the definition you need to remember. A class should have only one reason to change. See the shift? We're moving away from thinking about what a class does and focusing on why we would ever need to modify it. That right there is the key that unlocks everything.
So what happens when we don't follow this? What's the big deal? Well, you end up with code that's fragile, brittle, and a real pain to work with. Let's look at exactly why that happens. Okay, check this out. Imagine just one class trying to juggle all of this stuff. You've got your business rules, your database logic, sending emails, and creating reports, all crammed into a single file. Each one of these things has a totally different reason to change, and you know they will change, probably at different times and for different people. And that's when the chaos starts. Your code gets super fragile. You go to change the report format, and suddenly you've broken the email system by accident. It's a nightmare to maintain because you might have the database team and the business analysts all trying to edit the same file, causing all sorts of merge conflicts and bugs. Everything's just tangled up together, making it almost impossible to test properly.
So how do we actually spot this happening in our own code? And more importantly, how do we fix it when we find it? Let's walk through a really practical way to do just that.
It really just comes down to asking yourself a few simple questions. First, just be honest. How many different jobs is this class actually doing? Second, and this is a big one, who would ask for a change? Is it a database admin, a business analyst? If you can name more than one role, ding, 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 you've probably got more than one reason to change. And finally, think about the blast radius. If you tweak one little thing, what else could blow up? So on the left, we've got that classic God class that does way too much. The fix? We break it apart. We create a user repository that only talks to the database, an email service that only sends emails, a report generator that only builds reports. Now each class has exactly one reason to change. The whole system is suddenly so much cleaner and more modular. It's beautiful. Okay, but here's a word of caution. Like any powerful idea, you can definitely take this too far. If you just blindly separate everything, you can create a whole new kind of mess. People often call this over-engineering. This is a question I get all the time. So if separating is good, should I just break every single class down into the tiniest possible pieces? And the answer is a hard no. Trust me, you'll just end up swapping one problem for another. Instead of one big, confusing class, you'll have 100 tiny little classes, and you'll have no idea how they all fit together. The real skill here is finding that perfect balance. And here's a great rule of thumb. If you look at a class and it genuinely has only one reason to change, you're golden. Leave it alone. It's perfect. But the second you can clearly identify two or more different reasons for that class to be changed, that's your alarm bell. That's when you should start thinking about breaking it up. So when you actually apply this principle correctly, with that right sense of balance, what do you really get out of it? Let's talk about the true power of getting the single responsibility principle right. Oh, the benefits are huge. You get these nice modular components you can reuse all over the place. Your code becomes so much easier to read because every class has a really clear, focused job. Maintenance becomes a dream because changes are isolated. You can change the database without ever worrying you'll break the business logic. And of course, testing becomes way, way easier. What you're really building is a flexible system that can actually evolve over time instead of collapsing under its weight. If there is just one thing you take away from all of this, let it be this quote. It's probably the most powerful way to think about SRP. An actor, in this sense, is just a group of people who would request a change. Think of the accounting department as one actor and the database administrators as another. They're different groups with different needs. And here's the bottom line. When we design our classes to serve only a single actor, we guarantee that a request from one group of people won't break the code that another group depends on. So if the business team needs a new calculation, you only touch the business logic classes. If the infrastructure team wants to migrate to a new database, you only touch the repository classes. That separation, that is the absolute key to building software that is robust, maintainable, and just a joy to work on.